Okay, good morning. Hope you guys are doing well and had a good weekend. So let's see where we're at in the syllabus. So I think we're on to week 3. Alright, so we're going to do example 2.6 today, or this morning. The previous 4 assignments that we did are the examples did in class. 2.2, 2.4, 2.5, and the curve fitting one, these 4. Okay, so like I said in the email, I pushed back the deadline for the first 2, but the deadline's today. So the first 4 assignments, if you haven't done those already, those are due today. So you have till the end of the day, but people still need to turn in those assignments. So the first 4 assignments, the due date is today. Okay, and so yeah, there's still a few more people that need to turn those in, but is everyone good on those assignments, getting those in by today? Okay. Alright, so yeah, I didn't specify a time, so I guess you have, technically you have the whole day, so you have till midnight to do those. And at some point, maybe later this week or this weekend, I'll go through your first 4 assignments, and I'll post your grades or update your grades for the assignments. And so again, those are all due today, and let me know if you have any questions on those. But you have until midnight because I didn't specify a time for September 15th. All right, so let's do today's assignment, which is example 2.6. Alright, so you can open up the example 2.6 Word document, and then the spreadsheet of the template is the calculated NPV Excel file. So these 2, we'll start with those. Alright, so let's do, let me set this one up. And sorry, you might hear the gardener and my dog probably barking at the gardener, but hopefully both those things will stop soon. Alright, so this is going to be on the concept of net present value. And let me just read the synopsis, and we'll go through this one. Okay, so calculating NPV at Acrion. This is, Acrion is a hypothetical drug company. At the current time, at the beginning of year 0, Acrion is trying to decide whether or not one of its new drugs, Niagara, is worth pursuing. So Niagara is in the final stages of development and will be ready to enter the market in year one. The final cost of development to be incurred at the beginning of year one is $9.3 million, and Acrivon estimates that the demand for Niagara will gradually grow and then decline over its useful life of 20 years. So specifically, the company expects its gross margin, revenue minus costs, to be $1.2 million in year one, then to increase at an annual rate of 10% in year 8, and finally decrease at an annual rate of 5% in year 20, and then that's the end of the financing. So Acrivon wants to develop a spreadsheet model to capture its 20-year cash flows, assuming its cash flows other than the initial development costs are incurred at the end of the respective years. So using a discount rate of 12%, which is pretty high, for the purpose of calculating NPV, which I'll explain. The drug company wants to answer the following questions. So is the drug worth pursuing, most importantly, or should Acrivon abandon it and not incur the $9.3 million development costs? So that all that's saying is the investment going to give us a higher return than the initial cost? If it is, then it's worth pursuing. Or considering if it's not, if the cost is higher than the return, then obviously they shouldn't do it. All right, and then we'll change a few things with some charts and tables. And all right. So let's start a model, and this is an important concept and a nice one to do in Excel because Excel has a present value formula, and you'll probably use this if you haven't already in future projects. So let's go to the spreadsheet. Okay, so it's a pretty simple model, but it's got some important findings. And so the initial development costs, I think these are in millions. Yeah, so there you go. And millions of dollars, 9.3. So it costs 9.3 million to take this investment. It gives us a gross margin of 1.2 million in year one, and then that's going to increase for 8 years at 10% per year. And then we're still going to get a profit after year 8, but it's going to decrease at 5% per year, and the discount rate when we calculate the NPV is 12%. Okay, and then so we're going to calculate the gross margin in each of the years 1 through 20. And then the NPV will be the present value, or the net present value of all the cash flows, and then minus the development cost. Okay, so before we start, let me revisit the net present value, and so just so you guys understand what's going on here. All right, so there's a nice little video that you can watch whenever you have a chance on NPV and IRR, and I'll explain NPV and IRR. IRR is the internal rate of return. All right, and we are going to use this concept after we finish the exercise or at the end of the exercise. And the IRR is the interest rate or discount rate that would break even the NPV. So that would be the interest rate where you're basically indifferent between investing in the project or not investing. So usually you're looking to see if your NPV comes out positive. If it is, then it's worth considering or pursuing the project or business. And if it comes out exactly zero, then it doesn't make a difference if everything is right, whether you do it or not, because that's the interest rate where you break even. So it'll make sense when we do that after we solve the exercise, because it's important to know what interest rate kind of breaks even your net present value. All right, so take a look at that quick video when you get a chance. All right, so this little section in the textbook is on the time value of money. And so if you take a finance course or anything like this, you've probably heard of this concept before, but so in many business situations, you get cash flows over different points in time, right? And the company has to determine the course of action to maximize the cash flows, which we're doing here. So to make decisions when cash flows are received at different points in time, which is often the case, the concept here is that the later a dollar is received, the less valuable it is today, and that's because you have a decision to make. So money can either be received today, or it could be invested at an interest rate, and so therefore the longer you wait, the less valuable it is, and so you have to discount it, which is what we're going to do. Alright, so key terms will come through in this exercise are the discount factor, which is the factor in which you discount each future payment, and the present value, which is the present value of the project or business adventure whenever you factor in the discount rates and discount factors. Net present value is just the present value of all the cash flows minus the initial cost, and the discount rate is very important because that's the rate in which you have to discount this project, and it's also the rate at which you could otherwise earn interest in some interest-paying bank account. And so before we start, you scroll down to the bottom. I have some practice problems we'll get to if we have time, but just look at the simple formula. So this is present value. And this is telling you the future value is divided by 1 plus the interest rate raised of the period, and that's because each of the future values is worth a little bit less the longer you wait, and it also depends on the interest rate. So what you see here is there's a trade-off between future value and present value, because in present terms, the longer you wait, the less valuable it is. So if this is 10 years, it's going to be worth less. And so when we did this example, there's 20 years, so each year you wait longer, the less valuable it is today in present terms. And also, when the interest rate goes up for the discount rate, same thing, that makes the future value less valuable because you could alternatively invest this present value at that interest rate. So the key terms which determine how valuable it is today are obviously how much you receive, and then if the interest rate is higher or the longer you wait is higher, then that lowers the present value. Okay, and then the net present value is just this. You sum all these together and then subtract the initial cost. All right, so that's what we're going to do in the example, and we'll do some practice problems. Assuming we have time after the exercise. Alright, so step 1, we don't have any, we have inputs, we have objectives, we don't have any decision variables. We're not trying to decide what this should be, but we're trying to just calculate the net present value. So that's the purpose here. Just given the parameters, what is the net present value, and then given that, should we do the project? So step 1, let's just highlight the input cells light blue like we do, and the objective, which is NPV, that'll be the highlight yellow. So that's step 1. All right, so there's not a lot going on in this spreadsheet, but all the inputs, the titles and inputs, so these are inputs. Development costs, gross margin year one, peak year, rate of increase, rate of decrease, and discount rate. So B4 to B9, those are all inputs. You can color those light blue. All right, and then the NPV, which is, we're going to calculate that at the end, but cell B33, let's go ahead and make that highlight yellow, which is the objective. All right, step 2. Is just to create the range names that we need for this exercise. So we did this before, but there's not a whole lot to create here, but let's go back to the spreadsheet. All right, and you can go ahead and make a name for all of the inputs, which are in a nice block, so you can do them all at the same time. So if you want to select A4 to B9 and then do formulas, and then create from selection, and then it should default to left column, which will give the actual inputs a name on the left side, so just hit OK. We're going to need a range name for this whole gross margin area. So you got the name, but you got to select the appropriate cell. So if you start with gross margin, all right. So if you want to select and keep selected B12 to B32, let's give that whole range the name of gross margin, which is selected at the top. So select that range. Then under Formulas tab again, create some selection. And Excel knows you want the top row, which is going to be gross margin for that whole range. So hit OK. Can you show what you did after create some selection? Yeah. So for the gross margin one or for the previous? Okay. So let's. Yeah. So we're just doing range names. All right. So let's. The first group we did was this group. Okay. So if you selected A4 to B9 and then formulas, create some selection, and it should default to left column for this one. So just hit the OK button. And then for the second group, or range, you selected B12 to B32, and then under Formulas tab, create from selection, and this one should default to top row, so you just gotta hit OK. Alright, so assuming it checks the right option, just hit OK, and that should do it. So it's just, you're just naming the range names, and Excel usually knows that, what you want to do, but yeah. So that work? Okay, you're welcome. And the final range name is just for the objective, which is NPV, so you can go down and select A33 and B33, and then same thing. Formulas tab, create from selection. Excel knows that you want to name this NPV, so it chooses left column, and hit OK again. So those are the range names we need. To double check with the formulas tab checked, you can just hit the name manager. Alright, and just double check that you have these range names, which are development cost, discount rate, unit margin, gross margin, year one, MPV, peak year rate of decrease, and rate of increase. Alright, so if you have all those range names there, you should be good. If you don't, let me know and I will help you reselect them. Alright, step 4? Step 3. Alright, so step 3, you're going to put this formula in B13 and then this formula in B14 and copy it down. And so I'll explain what these are in a minute, but if you did the range names properly, it should come out pretty quickly. So let's do step 3, putting in these formulas in the bulk of the spreadsheet. Alright, so in B13, the first year, the formula is equals just equals gross margin year one, and so year one you get 1.2 million. So that's what we start with. So you should just see it selects the 1.2 from the range name. All right. But then make sure you get this one correctly in cell B14. The next formula is step 3. So the formula is we'll go through it a couple times. Equals. So choose the if function and in the parentheses. All right, so here's our formula. Equals if in the parentheses A14 is less than or equal to, make sure that's less than or equal to, peak year, comma B13 times parentheses 1 plus rate of increase, close the parentheses, comma B13 times 1 minus rate of decrease. Alright, so I'll explain this, but make sure you got, so this is a less than or equal to, this is a plus, and then this is a minus. So make sure you have those signs correctly, else it's going to give you a different argument. Okay, so this is telling us, it says if A14, which is the current year, so if the year we're in is less than or equal to the peak year, and if it's less than or equal to 8, then we're going to increase, because we're going to increase this investment up to year 8. Alright, so as long as the year we're in is less than or equal to 8, we'll increase it at 10%, so 1 plus 10%, or otherwise, if we're after year 8, we're going to decrease it at 5%. So this big argument specifies the whole thing we need. It's just saying that if the year we're in is left or equal to the peak year, increase it at 10%. If we've passed the peak year, we're declining at 5%. Okay, so I think you should get 1.32 million there. And if you got that, or if you got the formula, you can apply the formula down the rest of the cash flow years. So take that formula, if you got it nice, correctly from step 3, and drag the bottom right corner all the way down to the last year like this. All right, and look at it. I'm going to format these decimals because this is, I don't know why there's so many decimals, but so if you got that, and then I'll double check that everything's cut out, but if you want to just format this to have four decimals, that'll make things a lot easier. So if you select the full range, it looks like D13. Oh, what if you get reference? All right, so if you get hashtag REF, which is hashtag reference or whatever it is, that means that some of the, it's not, the formula can't calculate. Okay, so all right, so you got a reference number like that. I guess I was typing. If you get this, so if somebody typed in this, so they got this. All right, so if you get that, something's wrong with the formula or the calculation, so you need to double check the formula and the range name. So go here. So like this one is hashtag REF. All right, so click up on the formula bar and go through it and see if the things it's selecting are actual, like see how A14, make sure that's the year 2. Left new to the peak year, make sure that's got the 8. So if the range names are wrong, it's not going to work. E13's got to be the 1.2, and then times 1 plus, see how that's 10%, and B13 is 1.2, and then 1 minus rate of decrease is 5%. So make sure that the values it's pulling from are actual numbers, and if they're not, if you're pulling from something that's not a number, then it's going to give you a non-calculation. So see how if you look at the colors, I can tell that it's got actual numbers in it. Okay, so let's all right. So let me. Okay, so yeah, just this is the way I can look at it. So just post it under example 2.6, and when you do that, I'll look at it in a few minutes and try to see what I can figure out. So post it under example 2.6, and I'll take a look at it in a minute. All right, and then I had another question. Mine says false for a bunch of them, but I didn't get the same numbers. Well, that probably means that the if argument is specified correctly. So go back. So Trevor, yeah. Okay, so you got to make sure you look at the argument and if the logic is specified correctly. So you're specifying an if argument. So it's saying if this, calculate that, and after the comma, otherwise do this. All right. So if you look at this and see that everything is specified correctly with the signs, then it should do it because you're telling yourself if this is true, then calculate this part, right? Increase it at 10%. Otherwise, if it's not true, then decrease it at 5%. Oh, okay, good. All right. So, all right. So if we're here and you got the gross margin calculated, I was about to format this. So if you want to select B13 all the way to B32, and you can just format this, or let's just do this. If you go up here to the decimals, just hit the decrease decimal button until you have 4 of them. Or sorry, the increase decimal button. So I just formatted it so they all have 4 decimals, so it's easier to see what the numbers are. Okay, so now we got all these values here with 4 decimals in the millions. All right, and then the next step is to calculate the NPV. All right, so is everyone follow along here? Okay, and then let's do step 4, which is the net present value. All right, and then so here let's use the NPV formula that Excel has built in, and then we'll just subtract the development costs, and that'll give us the NPV right, of this investment project. So step 4, go to the objective cell B34. Sorry, B33 in this file, and then step 4, net present value equals. Alright, so we start with negative development costs, so make sure you see how it says equals, and there's a negative sign right there. So make sure you put that negative, because you got to pay the development costs. Alright, so equals negative development cost, and then plus. Okay, so you should have an NPV formula. Alright, so So choose that, and then in the parentheses, you specify the argument. So the rate means the discount rate or the interest rate. And you have a range name for that called discount rate. And then comma. So you can either specify all of the values that you're getting over the periods of time, or because we have a range name for all of those 20 values, just type it in, which is gross margin. Alright, so that's it. For your NPV is equals negative development cost plus NPV, and then in the parentheses discount rate, comma gross margin. Alright, and hit enter. So I think that's what you should get, 3.3003, and that's in millions. And what we did there is we told Excel to sum up all of these gross margins and then multiply them by the discount factor, which is 1 plus the interest rate raised to the current time period. And then we just subtracted the development costs. So we did that whole NPV calculation pretty easily with Excel. All right, did that work? Did we get the correct NPV here?
I got $0 on mine.
Okay. So what about these numbers? Are these similar?
Yes.
These are the same, but this is 0?
Yeah.
And it doesn't say, let's see, so when you selected minus development costs, so that's choosing a 9.3, and then plus NPV, and that's choosing a discount rate of 12%, and then comma gross margin, is it selecting the same areas of all this?
Yes.
Is it 0?
Mm-hmm.
No, that seems weird because it shouldn't be 0. And if all these values are the same, so you're telling Excel to, alright, let's try this. So just go to the NPV formula. Oh. Okay, so go to the NPV formula, which is D33. So just do NPV discount rate. Take away the development cost, and let's see what it does here. Alright, so just try equals NPV discount rate gross margin. We'll see what happens.
I still got 0.
Alright, so something's wrong with the so if you got 0, then that means that the sum of all these is 0. So if you click on this one, B32, does it look like this?
Yeah. Yeah.
Okay, so why don't you can you post yours to the Blackboard too, and I'll look at yours in a minute.
Okay.
So just go to example 2.6 and post it. And so let me look at Christina's real quick, and then I'll look at yours as soon as you post it, and then we'll catch up in a minute. But yeah, everyone just if you got double check you got 3.3003, which should be your NPV. If you didn't, let me know. If you did, Just give me a minute. Let me catch these other two students up. Okay, so someone got 21.90. Alright, you got a better investment. Okay, so let me look at this one first. Okay, so Christina, I think yours out. You had a. If you're looking at it now, I don't think you had a multiply sign right there.
Okay.
So just put you see that's missing in yours.
Let me see.
And I think that worked because I put the multiply sign.
Oh yeah, I understand the multiply sign.
So do that, and then it should work, and then just apply it down.
Okay, thank you.
You're welcome. Oh yeah, I think Dominic, I think you sent me just a blank one.
I thought I pressed right.
All right, and then so Ariana, do you want to post yours under example 2.6, and I'll look at yours too. Okay, good. Then maybe we got the same problem. All right, well, let me do the next step, and then once you guys post yours, I'll look at it. So let's do step 5, and then I'll double check those other ones. So we've done so the question here is the drug worth pursuing? You should act on abandon it now. and not incur the 9.3 million development costs. So you can see that this is the NPV that we calculated, which is about 3.3 million. So that includes, we've already subtracted the development cost. So after paying the development cost, we still get 3.3 million. And so that means that this drug is worth pursuing because the string of payments or investments over the 20-year period exceeds the initial development cost. So the drug is worth pursuing because they got a positive NPV. So the answer is yes, it's worth the development cost. Which one I open last time?
For some reason my computer doesn't want to find the actual one I did, so it's still struggling.
Oh yeah, so both of those are still the blank one. All right, so let me do step 5, and then if either of you it looks like Dominic and Ariana, you're having the same problem, maybe, because you got 21.90. So one of you posts showing up that you had 21.90, and I'll try to check it in a minute. Okay. All right, so I see the problem because you didn't subtract the development cost, so just put a negative sign here. So it should be equals negative development cost, and I think the rest is right. Let's see. Yeah, there you go. So just put a negative sign in front of the development cost, and hopefully that works for both Ariana and Dominic. Okay, so good, that worked for you, and Dominic, let me know if that works. Okay, I'm not even sure I think this is my file. Looks like it. Okay, so step 5. All right, so we're going to make a data table showing how MPV changes when the years, basically when the peak year changes. Okay, so we'll create a one-way data table showing how the MPV changes when the peak year changes, and we'll see which years are negative relative to the peak year. Okay, so step 5 is to make a little table. All right, so we're going to type this in. So starting in cell D11, D as in dog. Let's give this a title. Let's call this sensitivity of NPV to peak year. Alright. Sensitivity of NPV to peak year, and if you want to make that bold, like a title, you can hit the bold button, or Control B is also bold. And then right here in E12, let's just link in or reference the objective, which is NPV, so equals. Alright, so equals, and make sure it's this one, the range name. Okay, so equals NPV, which should pull in B33. And then let's count up some years over here. So starting in D13, type in 3. And then 4. And then count up to 10, so you can just 3, 4, 5, 6, 7, 8, 9, 10, or just select the two and it'll count up to 10. Alright, so let me fix the decimals, but this is what you want. You want
What was the for NPV right there? The 3.3003.
oh yeah, so this is just a link to the MPV link thing. So it should, you type in equals MPV or equals D33, it should link in. Does that work?
Yeah, I just linked it to the 3.0 something.
Okay, so make sure it's not just typed in, make sure it's equals NPV or equals B33.
Yeah, it equals B33.
Okay, that works. And then right here you got 3 through 10, so these will be the possible peak years that'll change. Alright, and so if we got this table set up, we can do it by selecting this area, E12 to E20. Okay, and then we can go to data and what if analysis and data table. Alright, and the row input cell is blank, and the column input cell is the peak year cell, which is B6. And you can hit OK. Yeah. Okay, so I'll redo the table one more time. Okay, so to do the table, so make sure this is equals MPV, and make sure you got 3 to 10 numbers here. And if you select the whole range, which is D12 to E20, and then data tab, what if analysis, and then data table. Okay, and then row input cell is blank, and column input cell is D6. And then if you hit OK, that should work, and give you the appropriate or the corresponding MPV if the peak year is this. All right, so if the peak year is 3, that's the MPV. If the peak year is 4, that's the MPV. And if you want to just format these to have 4 decimals to be consistent, you can also do that. All right, so okay, one more time. All right, so that equals MPV. In this range, D13 to D20, that's 3 through 10. And select all of it, D12 to E20. And then data tab, what if analysis, data table, column input cell is blank, and row input cell is blank, and column input cell is D6. Hit OK, and that should do it. Okay, you're welcome. So you should see that, so we know the changes as long as this cash flow, the cash flow is increased at least 4 years, we're going to get a positive net present value. If it only increases 3 years or less, then that's going to be a negative situation. It's not going to be worth it. So this tells you that the value has to increase for at least 4 years for it to be worth it. So we figured that out. Step 6 is one more data table. So here we'll make a two-way data table showing that how the MPV changes when two things change, both the peak year and the rate of increase. All right, so let's do that. And go back to the spreadsheet, step 6. All right, so go down to cell D22 and let's give this title here. Let's call this sensitivity of MPV to peak year and rate of increase. Okay, so in D22, this is just the title. So sensitivity of MPV to peak year and rate of increase. So when those two things change, what's going to happen to MPV? All right. In D22, this is going to be the link to the NPV again, equals NPV. Alright, so make sure that's equals NPV and it gets to 3.3003, equals NPV or equals D33. Okay, and then we want the years again down here. So I think the easiest thing to do is just copy and paste it. Alright, if you want to select the D13 to D20 and copy it, Control C. And then go right here and paste it. Starting in D24, Control V is paste. V is in Victor. Alright, and then across here we want to have some different rates of increases. And we'll start with 5% in E23. So 5% is 0.05. And then the next one is 6%, 0.06. And then you can count up to 10% just by selecting the two and then dragging it over like this. Alright, so we got the table set up. We had equals NPV here in D23, and then this is 5%, 6%, all the way to 10% in this range. E23 to J23, and then here, count from 3 to 10 in increments of 1, D24 to D33. Alright, so you're setting this up manually, so you can see what the NPV is if these two things change. What's the corresponding NPV? Okay, to make the table, select the whole thing, D23 to J31 like this. And then same thing, data tab. What if analysis and then data table. Alright, so the row input cell is B7. So that's the rate of increase, and the column input cell is the same as the previous table, which is B6. And that's for peak year. So row input cell is B7, column input cell is B6. Hit the OK button. Let's see if that works. Just gotta do a little formatting, but it looks like it worked. It looks like it gave us the NPV with the corresponding different interest rates, increase percentages, and then peak years. Okay, so if you want to select the inside of the table, E24 to J31, and just format it to be number with 4 decimals. Okay, home tab, format, then format cells. And if you want to just do number with the 4 decimals, that should be consistent with the other values. Hit OK.
Could you please do it again?
Yeah. So we'll do the table again here. Okay, so
Not the table. I just asked.
the format.
The format. Yeah, the format.
Okay, sorry. Yeah. All right, so you got this stuff here, and I'm just going to format it to look consistent with the 4 decimals. So select the E24 to J31. Yeah, the inside of the table, and then under Home tab, you want to choose the Format drop-down feature, and then Format Cells. All right, and when you get here, just change the category to number, and then up your decimal places to 4, and I think that's all we did. So number with 4 decimals, and hit OK. Okay, did I do it? All right, hopefully that worked. And then final step for this table is let's just see if we can highlight the negative values, so the situations in which this project would not be worth pursuing. Okay, so these are when the rate of increase changes. That's good for us. And this is the longer it increases in years, which is also good. But let's see the situations in which we would not pursue the investment. Okay, so if you highlight the inside of the table, E24 to J31, and then under the Home tab, you can choose conditional formatting and then highlight cell rules. And then less than. So conditional formatting, highlight cell rules, less than, choose that. And you want just less than 0, so just type in a 0 there where it says format cells that are less than 0, and hit OK. Okay, and you can see these are the situations in which, so if it only increases for 3 years, no matter what the rate of increase is, you can't do it. If it only increases for 4 years, we've got to have at least an increase of 10% or higher. And then if it increases for 5 years, you've got to have 7% or higher. And then if it increases for 6 years or more, then any rate of increase is still worth pursuing. So that's how you read the table. Did we get the table with the conditional formatting? All right, so we have one more step, and then we're done with this Excel example. So back to the steps. All right. And step 7 is just to calculate or figure out the IRR. So what's the internal rate of return? And we'll do that using the goal-seek feature. So remember, this is the interest rate or discount rate at which the NPV is exactly 0 given the parameters. Okay, so back to the model. All right, so click on the data tab, and then I think what if analysis. And you should see a feature that says goal seek. We're going to choose that. So data tab, what if analysis, and then goal seek. Okay, so we want to find out when NPV is 0 by changing the discount rate. So set cell, that's 833, okay, for the objective. To value 0, because that's what we're looking for. But I gotta scroll back up here. All right, let me come back to this because I can't see what cell, but actually. Okay, so it's B9. Okay, so we're going to set cell 833, which is NPV, the objective, to 0 by changing the discount rate, which is B9. So set cell 833 to value 0 by changing cell B9. And if you hit OK, it should work. Oh, that's B33, sorry. Okay, set cell B33 to value 0 by changing B9. Then hit OK. And it should say it found some solution. And it should implement the solution. So let's see if you hit OK. Okay, so it's telling us that NPV is roughly 0 when the interest rate is about 17%. So the internal rate of return is 17% or 17.03, etc. And we were looking for the discount rate at which the project is exactly 0, and that's about 17%. Did we get that? All right. We're done with this exercise, so save this. And if you're done with it, you can post it here in example 2.6, or whenever you're done with it. This one's not due until next Tuesday. Okay, so okay, so the ones that you posted for me to look at, you can just leave those and just post a newer one, and I'll look at the most recent one. So don't worry about deleting them, but just make sure you post your updated one. For those of you who are to look at here, Dominic, Ariana, Christina, I think Trevor might be done. Just post your current one, and I'll look at the most recent. Okay, let's let's look at the practice problems. So we're done with example 2.6, that goes here. Okay, so on page 2 of example 2.6, we have a couple practice problems. I posted solutions that we can look at here on Blackboard. Okay, example 2.6 practice question solved. Open that up. Alright, so just to make sure we understand the concept of MPV and PV and future value, let's look at a few practice problems and make sure you got my solutions here, but make sure you understand these in case one of these is on the take-home midterm. Okay, so there's the general formula for PV. Question A. If suppose the interest rate is 4%, what's the future value of $100 4 years from now? So you can convert easily this present value formula to future value. Alright, so if you just multiply both sides by 1 plus I to the n, you get FV equals PV times 1 plus I to the n, right? And that's what you need here. Alright, then just plug in the values. Present value is 100, and you have 1 plus I is the interest rate of 4%, which is 0.04, and you're going to leave that in bearing interest for 4 years, so n is 4. So the future value is 100 times 1.04 raised to the 4, and if you calculate that, you get about $117. So $100 at 4% compounded for 4 years is about $117. And then B, how much of the future value is total interest? Alright, so this is pretty simple, but if you have $117 and you started with 100, then you gain $17 in interest. And then part C, by how much would total interest be greater at 6% than at 4%? Everything else is the same. So you got to calculate the future value of $100 at 6%. Okay, so everything else is the same, but the interest rate is 0.06 now. And so that simplifies to future value of $100 times 1.06 raised to the 4, and that should calculate to roughly 126. Okay, so it's asking you how much would total interest be greater than 6% than the previous. So here you got $26 in interest in 4 years. At 4% you got 17, so you got an extra $9, where total interest would be greater by $9 at 6% compared to 4% if nothing else changed. Alright, then one more, where we get a nice little net present value for calculating stream of benefits over a certain period of time. So this is a simplified version of what we did in the 20-year Excel example. So Darth Vader Jr. is contemplating the purchase of a new Death Star that will cost $1 million and has a useful life of 3 years. The Death Star is going to yield year-end revenues of basically $500,000 in year 1, year 2, and year 3. Okay? And so we need to calculate the net present value of the Death Star if the interest rate is 25%. So those will be the revenues, but it costs $1 million. So is it worth it? So use this formula to get the discounted payment or the discounted revenue each year, sum those together, and then subtract the initial cost. So that's exactly what we did in the example, 2.6. So the NPV is, in year one, you get $500,000. Divide that by 1 plus the interest rate, which is 1.25, and in the first year, it's just 1. Second year, you get another $500,000, but now it's divided by 1.25 squared. Okay, it's worth less because you got to wait longer. And then finally, third year is 500,000 divided by 1.25 to the third term, or the third period, and then make sure you subtract the initial cost, which is $1 million. And this should come out nicely to, well, evenly, to negative 24,000. All right, so that means that the sum of the revenues in years 1, 2, and 3 doesn't cover the development costs. So should Darth Vader Jr. purchase the Death Star? And that's obviously no, because the NPV is less than 0. It's not worth the initial financing cost or development cost of $100,000 or $1 million. All right, so those answers are up on Blackboard. Let's make sure you understand the concepts here for a future take-home exam. And let me just revisit the syllabus, and we'll wrap things up for today. I think we're almost done. All right, so again, these 4 are due today. Example 2.2, example 2.4, example 2.5, and example the assignment curve fitting. So make sure you get these 4 in by midnight tonight if you haven't done so already. And then today's example, 2.6, isn't due until next Tuesday, but you can post that whenever you're done. And then on Thursday, we'll move on to chapter 3 and do example 3.1, and that'll also be due next Tuesday. Okay, so I think I think that's all we got for today. And make sure you get the first assignments in by today if you haven't done so already. But other than that, I'll see everyone Thursday morning, same time. And thanks everyone for participating today. So have a good rest of your week, and I'll see you Thursday.
Thank you, Professor.
Professor,
Yes.
I saw week 6 we do have a midterm exam, right?
Yeah, so it's a take-home exam.
Do we have a review before the exam?
Yeah, so what I'll do is I've put aside a day or two, at least, to do like a practice exam. And so let's see. It's due on the Tuesday, October 6th. Okay, so I think either one of these 2 days, September 29th or October 1st, I don't have an exercise scheduled, so one of those 2 days we'll do like a practice exam in WebEx. So that'll be our lecture. So yeah, we'll do a practice exam one of those 2 days, and that'll help you prepare for the take-home exam.
Thank you.
Yeah, so don't worry about it right now, but yeah, during week 5, we'll do a review and a practice exam, and then you can look at that for your midterm.
Looks great.
Okay.
Bye.
Okay, bye.